So just to start, cube roots, what do they look like? They look like this, but they have a little 3 right there. Okay? Now before, we had square roots, and square roots, they just look like that. And if you don't have a number right here, you have to automatically assume that it's a 2. Okay? But this would be a cube root, and tomorrow we're going to be doing 4th roots, 5th roots, 7th roots, right? Yeah, all kinds of different roots. Today we're only going to be doing cube roots. Let's start these notes by looking at perfect cube numbers. Let's make a perfect cube number list. So when I think about perfect cube numbers and I make the list, I'm going to start with the number 1. What's the next number on a perfect cube number list? 8.
And then 27.
And then 27, you're right.
64.
And then 64, that's right. You're just reading it from the board. That's messed up. Okay, so where are these numbers coming from? 1 cubed, that means 1 times 1 times 1 is 1. 2 cubed, 2 times 2 is 4 times 2 is 8. 3 cubed, 3 times 3 is 9 times 3 is 27. 4 cubed, 4 times 4 times 4 is 64. 5 times 5 is 25, times 5 is 125. 6 times 6 is 36. 36 times 6 is 216. And you could keep going forever, right? Now, I know you're thinking, well, I can't do 6 times 6 times 6 in my head. That's why we have calculators, right? So if you wanted your next perfect cube number, what I would do is get a calculator, and I'm going to take this moment to explain what that looks like on the calculator. On the calculator, you would do 7 cubed, and you get 343 for your next perfect cube number. Now, let's look at the Casio first. The Casio is pretty awesome because it has this exponent button. Okay? So the first thing to do would be to type in, if you wanted 7 cubed, you would actually type in the number 7. Type in the number 7, and it'll appear right there. And then you hit this button, and it'll open up a little box right on the exponent position. So then you hit 3, and it'll look like 7 to the 3rd. Hit equal, it'll give you 343. Okay? Now on the Texas Instrument, it doesn't look that great because it doesn't have this little button right here. It doesn't have that button. But over here on the Texas Instrument, we're going to be using the caret button. That's what it's called, that little flechita, that little arrow that's pointing up. Okay? So if you wanted to do 7 to the 3rd power, you would type in the number 7, and then you would hit the little caret button, and it'll put the little arrow up there, and then hit 3. And even though it looks like a regular 3, it's actually an exponent. This button, whatever comes after this button, is an exponent. So right here it really says 7 to the 3rd power. So if I did go 7 times 7 is 49, 49 times 7, it'll give me 343. So there's other things that you could do on these calculators. You could do square roots and all kinds of other fun stuff. But right now, I just wanted to show you how to actually type in an exponent right there. Okay, so I hope we're cool with perfect cube numbers. We simplify cube roots the same way we simplify square roots. You guys don't have to copy this down, but let's just pay attention here. We simplify square roots the same way we simplify, cube roots the same way we simplify square roots. On a square root, you want a perfect square number. On a cube root, you want a perfect cube number. And if you don't have it, you could rewrite it with multiplication to get that perfect cube number. But let's not even start with that. Let's start out with something simple. The cube root of a perfect cube number is a perfect answer. Go ahead and copy this down. How about just the examples? You don't have to copy down that the cube root of a perfect cube number is a perfect answer. But let's copy down the cube root of 8. And what is the cube root of 8? 2. That's right. Now, if I said y, that's right. 2 times 2 times 2 gives you the 8. Okay? How about number 2? What's the cube root of 125? 5. Why? Why is the answer 5? 5 times 5, 25. Times 5 is 125. So you want a perfect cube number inside these cube roots. Okay? You want a perfect cube number inside of the cube roots. And we'll get to breaking them down and rewriting them with multiplication on the next slide. But right now, here's an interesting fact. Whoops. Interesting fact. The cube root of a negative number, it's real. It's not imaginary, right? So there is no I when it comes to cube numbers, cube roots. Now remember in square roots, if I said if I said, let me write this down over here on the side. If I said, what's the square root of -9? You would say that the answer is what? 3i. There is no real answer that'll give you a -9, right? So if I say, what number squared gives you a -9? Well, 3 squared doesn't give you a -9, and -3 squared doesn't give you a -9 either. There is no real number. That's why we put the I. It's imaginary. But when we do the cube root of a negative number, you don't get imaginary. You actually get an answer, a real answer. What is the cube root of -64? Anybody? -4. It's not 4i, it's not -4, it's just -4. Now if I asked you, if I said, why is that? Well, because -4 times -4 is +16, times -4 will take you to that -64. Make sense? Okay, so right here you actually get an actual answer, -4. How about the next one? What's the answer to number 2? What's the cube root of -27? -3. Why is it -3? Because -3 times -3 times -3, that will actually get you the -27. Make sense? Okay. So the main idea is you do want to have a number that you could multiply with itself 3 times to get that value inside the cube root. Now, if I did 2 times 2 times 2, what do I get? I get 8. Now, if I go 3 times 3 times 3, do I get 24? No, I get 27. So I wrote my perfect cube number list up here. So if I don't have, 24 is not a perfect cube number. But could I rewrite it with multiplication to get one of these perfect cube numbers? Yeah. What's it going to be?
I don't know.
12 times 2?
Yeah.
No.
4 times 6.
4 times 6? No.
Yeah.
Look at this. 8. 8 times 3. You want a perfect cube number, right? Just like before, on square roots, you wanted to rewrite it with multiplication so you could get a perfect square number. Right here on cube roots, you want to rewrite it with multiplication to get a perfect cube number. So you're not going to say 12 times 2 or 4 times 6. Right here, you are going to say 8 times 3. Now, why do I want 8 especially? Because 8 is a perfect cube number. That way, when I split the root, the cube root of 8, the cube root of 3, when I do the cube root of 8, I get a nice, beautiful answer. What's the answer to the cube root of 8? 2. Now, what is the cube root of 3? Could I actually do that? No. So I just rewrite it, cube root of 3. Now keep in mind, if you're doing cube roots, you need to put that little 3 in there to represent that it's a cube root. If you just put the radical symbol, I'm going to automatically assume it's a square root, which would be the wrong answer. So that's your final simplified answer on number 1 right there. 2 cube root of 3. How about number 2? Let's think about this. 128, is that a perfect cube number? 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So obviously it's not up there. Now I want to rewrite it with multiplication so I could get a perfect cube number. So what would I rewrite it as? 64 times 2. And again, you could just get a calculator and do 128 and try to divide it by 8, try to divide it by 27, try to divide it by 64, and you'll see that 64 times 2 really is 128. So that's what I'm going to rewrite it as, 64 times 2, and then I'm going to split the third root to each of them. And the third root of 64, what is that?
4.
That is 4. And what's the third root of 2? You leave it, third root of 2. So that's your simplified answer for number 2. What do you guys think? Now you try. The cube root of 375. So some of us got the answer, and some of us still don't understand this. Let's all pay attention, please. Now, if it's the cube root, you want a perfect cube number. I have the perfect cube numbers up here. All you have to do is get a calculator and do 375 divided by 8 divided by 27. Go for the highest one possible, which is going to be 125. If you go 375 divided by 125, you will get 125 times 3. That'll give you 375. So let's rewrite that as 125 times 3. And let's split the third root on each of them. Now we all know that the third root of 125, it's going to be a perfect answer. What's the answer? 5. Why is that? Because 5 times 5 is actually 125. So this is 5. And then the cube root of 3, you can't do it. So you're just going to leave it. Cube root of 3. Again, you need that little 3 to show that it's a cube root. If you don't put the 3, that means square root, which is the wrong answer. Okay, guys. Now, we already know this from square roots. A square root is the same as the power of 1/2. So, for example, the square root of x, let me do this in blue. The square root of x is the same thing as x to the 1/2 power. And that comes in handy, right? Especially because you might have like the square root of x to the 8th. What is the square root of x to the 8th? Not cube root, square root. What's the square root of x to the 8th? That's x to the 4th. Because the square root is really the power of 1/2, so this square root is really the power of 1/2, and the power to a power you multiply, so 8 times half is 4. So that comes in handy with square roots, knowing that the square root is the power of 1/2. Now read this part right here. A cube root is the same as the power of 1/3. Okay? A cube root is the same as the power of 1/3. So if I had x, and let me put the cube root of x, that's the same thing as x to the power of 1/3. And this will also come in handy. Okay? Now, remember, when we did, let me put a line here, let's do some examples. When we did the square root of x to the 12th, that was awesome. Why? Because the answer is easy. What's the answer right there? The square root of x to the 12th. The answer is x to the 6th. Square root. Notice, I didn't put a 3 in there, right? Okay. So over here, if I did the cube root of x to the 12th, that's really, instead of dividing by 2, it's really dividing by 3. Because after all, the third root is really the power of 1/3. So that's really dividing by 3. So what's my answer going to be on that example? X to the 4th. That's right. Now, if you wanted to show some work, you could say, okay, this cube root is going to change to the power of 1/3. You don't have to show this work. And on the inside, you have x to the 12th. Power to a power, you multiply. 12 times 1/3 is really 12 divided by 3. That's how you get x to the 4th. So when we're doing the cube root of a variable to a certain power, we love for that variable to be divisible by 3. So taking a look at this one, the cube root of x to the 15th power, what is that really? That's really x to the 5th. So it's beautiful when you actually have the power that's divisible by 3, because after all, the third root is the 1/3 power, right? It's divisible, dividing by 3. Now, what if you don't have something divisible by 3? Like what if I had, let me put this right here. Let's say the third root of x to the 16th. Well, that's not divisible by 3. So what we're going to do is rewrite it with multiplication. Okay? So we're going to say x to the what? Instead of x to the 16th, we're going to say x to the 15th times x to the 1, right? Which is just x. You don't even need that 1 up there. Let me erase it. And then we're going to split the third root. Split the third root to each of those. And then now you could say, okay, x, the third root of x to the 15th, what is that? X to the 5th. And the third root of x, you just leave it, the third root of x. What do you guys think? It's the same process as simplifying square roots. Square roots was the power of 1/2, which means divisible by 2 on exponents. The third root is the power of 1/3, which means divided by 3 on exponents. Let's try a couple more. Everybody jot that down. The cube root of x to the 23rd. Okay, the cube root of x to the 23rd. Is 23 divisible by 3?
Yeah.
It's not. So what we want to do is rewrite it with multiplication to get a power that's divisible by 3. So what could I do? 7 times 3?
Yeah, that's
Okay. So we want 21 up there, right? Instead of 23, we would like a 21, something that's divisible by 3. So what I want to do is I want to take this x to the 23rd, and I want to rewrite it as x to the 21 times x to the what? 2, that's right. And now we're going to split the third root. We're going to split the third root. And now we could see that the square root or the cube root of x to the 21, that's actually x to the 7th, right? You could just write it without showing your work, but I want to show my work here. The third root is really the power of 1/3. So I really have x to the 21 to the 1/3, and a power to a power you multiply. When you go 21 times 1/3, that's like saying 21 divided by 3. So x to the 7th is your answer. No more radical on it. No more third root on it. It's just x to the 7th. Now this other one, there's nothing to do there. You can't do the third root of x squared. So let's just bring it down and put it there. Third root of x squared. So there's your answer. X to the 7th, third root of x squared. Go for it, guys. 14 is obviously not divisible by 3. So what are you going to rewrite that as? 15. You can't magically add another x. So you have to go, yeah, but that's good. That's a good good mistake. That way we could talk about it. You can't magically add another x, so you can't make it x to the 15th. But you want to break it down smaller. We're going to say x to the what?
13.
X to the 12th, because 12 is divisible by 3. But x to the 14th, you're not just going to rewrite it as x to the 12th. You're going to rewrite it as x to the 12th times x to the 2. Because remember, you add these guys to get the 14. 12 plus 2 is 14. And now we're going to split that third root. Split the third root. Split the third root. And the third root of x to the 12th without showing work. What's the third root of x to the 12th? X to the 4th. And the third root of x squared, you're going to just leave it, the third root of x squared. That's your final answer for that one. Now, the only thing left is to combo the numbers inside there with the variables. Jot that down, please. So check it out. Number 1, I have the cube root of all this stuff. So let me split it up. Now, I could actually do the cube root of -8. What's the cube root of -8? -2. What times itself 3 times gives you -8? -2 times -2 times -2 gives you -8. So right there, the first part of your answer is -2. It's not imaginary. It's not 2i. It's actually a -2. Now this next one right here, the third root of x to the 6th, that works out beautifully. X to the 2nd. Now, why is it x to the 2nd? Because remember, this third root is really the power of 1/3, which means divided by 3 when you multiply power to a power. So 6 divided by 3 is 2. Okay. Now, if you are still confused with that, you could actually show your work if you wanted to by doing the parenthesis and the 1/3 power and then multiplying the 6 and the 1/3. But this last one, this is the interesting one. You want something that's divisible by 3. You don't want y to the 10th. So let's go y to the 9th times y. And now we're able to split the third root and the third root. So when I go the third root of y to the 9th, that is y to the 3rd. And when I go the third root of y, I can't do that. I just rewrite it the third root of y. So here's our answer, this in blue and this in black. But I need to rearrange it. Actually, it's already arranged perfectly. Our final answer is -2 x squared y to the 3rd, third root of y. Let's try the last one right there. The third root of 24 n to the 4th. Well, I'm going to split the root. And the third root of 24, 24 is not a perfect cube number. So you need to rewrite it with multiplication to get a perfect cube number. Now 24 is not that big, so you could actually just start thinking, okay, what's 2 times 2 times 2? That's 8. 3 times 3 times 3 is 27. It's already too big. So we're going to use 8, the perfect cube number 8. So I'm going to rewrite it as 8 times 3. And I am going to split the cube root. And we all know that the cube root of 8 is what? 2. And the cube root of 3, I'm just going to bring it down. And now the same thing over here on this guy, you want it to be divisible by 3, so it would be a good idea to rewrite the end of the fourth as n to the third, because that's divisible by 3 times n. Because n to the third times n to the 1 is the same thing as n to the fourth. And now when you split the third root there and the third root over there, the third root of n to the third, that's just n, no more radical. But the third root of n, that actually comes down the third root of n. So here's your answer in blue. All you have to do is rearrange it. I'm going to put the 2 and the n together, 2n, and then I'm going to put the cube root of 3 and the cube root of n together underneath 1 cube root, 3n. And that is your final answer. Ladies and gentlemen, we will have these exact type of questions on the test Friday. Number 1, right here, there's a negative 2 on the outside. I'm just going to bring that down. And then I'm going to have the cube root of 256, the cube root of x, and the cube root of y to the 6th. Now, 256 is not up here on the perfect cube numbers. So I'm going to rewrite 256 as, I need to get a calculator and divide 256 by one of these numbers. So with the calculator, we found out that 256 divided by 64 is 4. So we could rewrite 256 as 64 times 4. And of course, we have the cube root on both of those. So the cube root of 64, that's just 4. Let's not forget about this outside negative 2. So you have negative 2 times 4, Brianna. And of course, we still have the cube root of 4 right there. And also the cube root of x that comes down. And the last one, that one works out nicely. What is the cube root of y to the 6th? Remember, a cube root is really like a 1/3 power. It's like dividing by 3. So what's the cube root of y to the 6th? Y to the 2nd. So our final answer will be negative 2 times 4, that's negative 8. And then I'm going to put the y squared right after that nice number, negative 8. And then I put the radicals together underneath the same radical, the third root of 4x. That is our final answer for number 1 on this slide. The next one, we have a negative 3 on the outside. Let me zoom in. So we have the negative 3 in the front, 162. Let's think about it. Which of these numbers could work into 162? With the calculator, 162 divided by 27, that'll give you 4. Yeah? So with the calculator, 162 divided by 27, we get 6. So we're going to rewrite it as 27 times 6, correct? And then we're going to split the third root and the third root. Now the third root of 27, that's just 3. So you really have negative 3 times 3 times the third root of 6. And then we're going to split that third root to the other terms, the third root of x to the 9th and also the third root of y to the 4th. Now we love having something that's divisible by 3 because the third root is really the power of 1/3. And when you multiply, it's really like dividing by 3. So this answer right here is going to be what? X to the third. Now the other one, we're going to have to rewrite it. We're going to go third root of y to the third times y. That way you could split that third root. So the third root of y to the third, that's just y. And the third root of y is simply the third root of y. Let me bring down the rest. I have a negative 3 times a negative 3, that's a negative 9. I have the third root of 6, that comes down. I have times x to the third times y times the third root of y. And now let's just rearrange it. Let's put our nice number first, negative 9, and then our nice variables, x to the third, y, and then our radicals, which in this case are third roots of both 6 and y together underneath one radical. type of questions will be on the test. Please watch this video over, study these questions.